Leetcode problem. 200 number of islands. I solved this problem by using unified and posted the video, but this time I would like to use the basic way because normally in an interview, if we find a problem and we should use the easiest way to solve it, not the difficult way. Only if we are asked to use the difficult way to solve it, then we can use unified. Now let's try to solve it by the DFS directly. So we are giving a m times n to the binary grid. So inside the grid, it will be binary string 1 and 0. So 1 means the land and 0 means water. We just need to find the number of island. So it means the number of the land. So for the first example, this area is connected because the island, this one, if it is a four direction connected, it means from the top down, left and right is connected. So this area is just one island. So we will code it as one. So for this example, this area will be one island, and here will be another island, and this corner at the bottom right. So this will be the third island. So we're gonna return a 3. Now let's try to solve it by using DFS. So let's define a DFS function. And currently, I'll give a path for the DFS. And I will design my main function from here. So I will give a result, and I'm gonna prepare the R and C is the rows and columns. So it will be the length of the grid, and C will be length of the grid 0. So it means the number of columns. And then by using 2 for loops, so for R in range R and for C in range C. Now we are going to check. So if this grid with R and C is an island, so if grid R with C equals to string 1, so this means it is island. So what we're gonna do, we just need to use the DFS to search. So inside the DFS, it will be directly R and C, and then result plus 1. Finally, we just need to return the result. So this DFS means if we find this is an island, so we're gonna recover all the areas to be 0. Next, we're gonna find the next ones. So here we didn't find the next ones, so we're gonna return 1. So for this example, if we find this one and this one and this one and this one, so they are connected, so they are an island, we can use the DFS to search. So we will recover all these areas to be 0, and then we're gonna search row by row to find the next one. So here is another one. We will recover it to 0, and we are going to search for the next one. Here, this one, it is connected to this one, so we will recover all these areas to be 0. Now we are going to write the DFS. So inside the DFS, it will be R and C. It means the grid in the position with the row and column. Now we are going to do some check. So if this R less than, let's write, if R less than 0, or C less than 0, or R equal to the capital R. So this is just for checking if it is out of range. So if C equals to capital C, or if grid RC equal to 0. So this just means if it is out of the boundary. If it is a 0, it means it is water. We don't need to check. So what we're gonna do, we just need to have a return. Because we don't need to check anything. Because this is a if condition, we can use a return. If it is a for loop, we're gonna use a continue. So here, Yeah, if it is out of boundary or if it is water, we don't need to do anything. We just give a return. Otherwise, we're gonna recover the grid first. Yeah, for this position, we're gonna recover it to be 0. So the grid R and C equal to 0. We're going to assign it to 0 because we are going to search from this position. So this is just similar to the visited set. So yeah, we just make it to be 0 for the next one. We're going to not revisit the previous one because this one has already been set to 0. So it will be just to search other areas, which is 1. Yeah, like the right and the bottom. Yeah, so it will be like that. Yeah, so this is just like a visited set, but we can put it in place as 0. It means we will not go back. Now we just need to use the DFS to search for directions. So the four directions will be R plus 1 with C and DFS R minus 1 with C. This means just the right and left. Now let's go to top and bottom. DFS R C plus 1 and DFS R C minus 1. Yeah, so this is C plus 1 just means bottom and C minus 1 just means top. So these are the four directions. Yeah, so for all the four directions we're gonna search. If it is out of boundary, we just give a return. Otherwise, we're gonna set it to 0. So all these areas will be set to 0. Yeah. Now let me submit it to check if it works. Maximum recursion. Yeah, this is a DFS R. Let's see. Yeah, I think here should be 0. If it is a 0, we're gonna return. Now it is 1. So here for the grid inside, we need to set it as 0 because this will be a string. Otherwise, for the next DFS, it cannot check it like 0. Yeah, we have to set it to be a string 0. And then for the next DFS, it's gonna check. If it is a string 0, it's gonna just return. Yeah. Otherwise, there is no return of this condition. So of course, so the depth will exceeded. Yeah, for the recursive function. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Now let's analyze the time complexity. So for this way, we just use the DFS to search all the positions, but this is a for loop. So this is m times n. M is the length of the grid and n is the grid I. Yeah, row and column, m times n. But for this one, this DFS actually it didn't take the time because while we are using DFS for the first one, all these areas will be 0. So for the next time, it will not using DFS to check. So the time complexity is still m times n. So 300 times 300 is the time complexity. And the space complexity, let's check the space complexity. Yeah, because this is just in place. We didn't take any actual memory. Yeah, because while searching, we didn't use the visited set. We just search it in place. But we still use the DFS function. This DFS is to search, yeah, search for the function calls. So for this DFS, it may have yeah. So the space should also be m times n. Yeah, because for this DFS, the recursive function, yeah, would also search. So the space complexity should be log n. Yeah, because for the DFS, it's gonna search for places and for the next. Yes, that's all. I think the space complexity should be O1 or log m times n. Yeah, but it's basically in place. Thank you for watching. See you next time.